Hello, my fellow YouTubers. Sorry about my last video. I ran out of storage on my phone, so bam, part two, I guess. And this is on Ed Leedskalnin's magnetic wheel. We're going to focus on the bar that goes across the front. When you look at the picture of Ed, there's a box, the wheel, the box, and a metal bar that goes across the top. That's a steel bar. And got the voltmeter hooked up. Let's go ahead and move the wheel. Watch the voltmeter. You see it move, right? Okay. Now if I take a V-shaped magnet and run it over the top of the bar in the center, you can see the voltmeter do some numbers, right? Pretty cool stuff. So, watch what happens when I'm going to move with my leg, the wheel gently back and forth, and I'm going to go across the top here. Now watch the voltmeter and see if I can do it. You can see it go up there in numbers, right? And what I'm doing is moving the bottom and moving the top. And I just got stuck with the magnet. Alrighty. Strong magnets. So you can see by moving the bottom and the top, we got a lot more stuff going on with the voltmeter. So imagine the box up front. This is the picture Ed now. The box up front's got the metal bar going across. The bar goes across like this. The magnets sweep underneath the bar at the center of the box. So that'd be the center of the coil there. Now this coil here, the key here is you guys out there building your wheels or having Benini wheels. This here has the core, iron core with a copper core around the iron going down about, I'm going to say about down to here. So this is catching the core, the copper coil is just right here. So it shows you the copper don't have to be down the pipe, but the core has to be in the copper at the top. And that's probably what that thing is. If it's a capacitor, it's a capacitor with this feeding core of coil underneath it. Maybe something unique. So, remember I was talking in my other video about layers. Well, here's bismuth, okay? Now I'm going to set bismuth on top, because this demonstration here is going to prove that adding different layers of metals makes a difference. Now let's take a magnet and let's watch the voltmeter, and let's swoop see if I can catch both. Let's swoop by there. Okay, look at the numbers jump up. And I'm swooping, and you can see the numbers. And that's bismuth. So now, let's put a piece of bismuth. For the first time, let's come over to the section over here of some goodies. I got some, what is this? This is some magnesium. Got some gold, silver, copper, nickel, copper here, and this is tin. Gotta melt that tin down. I'm gonna make a magnet, you guys. It'd be cool as that. Let's just go with a piece of copper, I guess, on top of the bismuth. Oh, put a magnet on top of the bismuth. Hold on, look at, there's the copper. Let's grab a damn neodymium or something. Got some here. I'll grab this regular magnet. Okay. We'll put it, let me see. Where's our compass? So this magnet is set up south, north. Okay, you guys can't see that. North, south. So we want south. So let's face the south down. And put that bismuth there and then the magnet. Let's go ahead and put one more layer of bismuth on top of that. So we have that set up like that. Okay. And let's go ahead and run the magnet by it. It's hard to do this with both hands, but alright, so layering it like that didn't really increase anything. Let's leave the magnet on there and see. No, that didn't do it either. Let's take the magnet off. So just having the bismuth on top of that right there. Yeah, it overload, yeah. So yeah, there you go. Bismuth on top. Making a big difference. Got this puppy all tuned up. Did a nice oil job down here because you know these. If you guys are going to use blocks, you know they don't move fast, but they do have centrifugal force once you get them going. And right now we're not really interested in how we're going to turn it or how it turns or how fast it turns. But it looks like I don't need to turn it fast. It's about the changing of the guard here, the two poles through induction through this pipe, which is connected to the ground, which is making a big difference. I see you guys leaving your comments there. I appreciate it. Leave your comments. There's a lot of different apparatuses out there that, let's try this now. Let's pull this off. This is one of my special makeups. There's bismuth in the middle. We'll set that on top there. And it's a nice little top hat there. And then let's go ahead and look at the voltmeter. And we can see that I'm just going past it. And I'm hitting overload. So you can see that that makeup too makes a big difference. Another thing I wanted to show you, let's take the magnets off. And let's take the magnets off. Watch how responsive this coil setup is, because look, no magnets on the wheel. Now if the block is magnetized at all, I mean, I doubt it. You know, it may be. Down bottom. Right now it doesn't appear to be. Oh, there you go. So the top of this thing is north. See, it is. The whole block is still magnetized. It's turning around, it's turning around, it's turning around, it's turning around. Down bottom is south. Up top as we go up. Come back to north. So we can now have two reference points on the wheel according to the compass. But I want you to see, like, the voltmeter, how responsive this still is. And I'm just turning the wheel. No magnets on it. But obviously it does have a magnet. Has its own built-in, because I had the wheel together for 4 years. All right, guys. We're gonna figure out what that is all about, and we're gonna incorporate it in here. And with Ed talking about all these different things that have positive and negative, and everything's a magnet with a smaller magnet built inside of it, and if something can go through brick or or steel or anything. It has to have a smaller orbit than the orbit that's in front of it. Same way water principles work. If you want to clean water and filter water, you're going to have a filter smaller than the water molecule, and you'll stop you get everything out of there. So same principles work all the way around. All right, guys. Peace out. Leave comments. I love them. Leave the comments.